Hello and welcome once again to my SOA Exam P video series, and we're going to be looking at a somewhat fun little problem involving probability and set theory and a little bit of fancy tricky algebra. And so I will begin with the formula for probability of A union B. It equals the probability of A plus the probability of B minus the probability of A intersection B. We saw this a little bit in the very first video, this principle of inclusion and exclusion, and we're going to be using it here, and we're also going to be using the law of total probability. We'll see that in just a minute. So what I can do is, well, we see that probability of A union B equals 0.7, so I can go ahead and use this formula. I can say probability of A plus probability of B minus probability of A intersection B equals 0.7. I also have one for probability of A union B complement. That little accent mark is the same as B complement. So this 0.9 figure is going to be probability of A plus probability of B complement, I'll use their notation, minus probability of A intersection what? B complement, right? Okay. So we've got that. Now, here's where the trick comes. What we can do is we can add these two equations together. Put a plus in between here. Probability of A plus probability of A equals 2 probability of A. Probability of B plus the probability of B complement. Well, B and B complement, B is event B happening, and B complement is event B not happening. The probability of the two together adds up to 1. Okay, the next one is probability of A intersection B, and what I'm going to do is I'm going to do it like this. Intersection B plus probability of A intersection B complement, and then the right side 0.7 plus 0.9 is 1.6. Now, this little thing in the parentheses here does have a specific value that it's going to be according to the law of total probability, which I'll show on the next page. So here's the law of total probability. It says the probability of A is equal to the probability of A intersection B plus the probability of A intersection B complement. Now, let's think about this. This is basically A and B happening, and this is A and not B happening. Well, if we include all of the instances where A and B occur, and then we add in all the instances where A occurs without B, well, effectively we have included all of the instances where A happens. In other words, there's no third option. You can't combine A and B, combine A and not B, and have some third option where A still happens. You either have B or you have not B. There is not a third possible option. So that adds up to probability of A. Now, let's bring this back to our equation that we had just had. And here we see this thing inside the parentheses is exactly equal to probability of A. Well, there's a few interesting things that happen here. We have 2 probability of A minus 1 probability of A, and that gives us just probability of A plus 1 equals 1.6, and then the algebra gets really, really easy. All we do is subtract 1, and we have probability of A equals 0.6 when we subtract the 1. So this is a kind of fun little problem, and It's one, there are other ways to do this, but this is the most intuitive way to my mind. If you have a different way of doing it that's intuitive as well, please respond in the comments. I've seen it done other ways, but this is the way that makes the most sense to me. But perhaps I could be persuaded to see it another way. I do know that the two-way table that we did in the last problem will not work with this one very readily because we do not quite have enough information to fill in those little boxes. So as far as I can tell, this is the way that I would do this problem, and it's kind of an interesting and fun little problem.